Hello students, I today discuss simple Harmonic motion. This is lecture 2. I have already discussed simple Harmonic motions definition in previous lecture. So I today discuss the velocity of the of a particle which executes simple Harmonic motion. So here I have taken a circle which center is O and a point P which is rotating through the circle anti-clockwise. So here P makes a angle theta and the P have a projected point N. So perpendicular I have taken and N is the projected point of P. So when P is rotates anti-clockwise through the circle, then N executes the simple Harmonic motion through the diameter x axis. So here I have taken P is angular velocity omega. Omega is the angular velocity of P and the linear velocity of P is Vt. This is the linear velocity of P. So Vt is the linear velocity, so it must have two components, a vertical component Vt cos theta and a horizontal component Vt sin theta. So here actually Vt sin theta is the velocity. This component is the velocity of the particle which executes simple Harmonic motion through the diameter. So here also we know that from the rotational physics that Vt is linear velocity is equal to diameter angular velocity. So this is the relation, and linear velocity is equal to diameter multiplied angular velocity. So here I have written the two components Vt sin theta which acts along x axis, or this is actually parallel. They have both same direction and this component have same direction. So and Vt cos x perpendicular to x axis. So Vt cos theta is perpendicular to the diameter x axis. So we will take just consider Vt sin theta which is the velocity of the particle executes simple Harmonic motion. So V is equal to minus Vt sin theta. I have taken negative sign because the displacement and the velocity of the particle which executes simple Harmonic motion are opposite in sign. That's why I have taken negative. So this will be minus a omega sin theta. Vt is equal to a omega. Now this is the velocity of the particle which executes simple Harmonic motion for the point N. So it is equal to minus a omega sin theta. Now we will consider where it will be maximum and minimum. If V is minus a omega sin theta, it can be written down in this way, minus omega a sin theta. Here you can generate again circle O. This is X, this is A, this is the point P, this is N. So this is X and this is theta. So here sin theta is equal to x Pn by OP, Pn by OP. So if we put OP is the radius, so it is equal to A. So we will cancel each other. Then Pn is equal to will be by Pythagorean theorem root over a square minus x square. So this is plus minus root over a square minus x square. Now when x is equal to 0, if x is equal to 0, then V will be maximum. If we take it is 0, then it will be maximum. So its value is plus minus omega e. So the projected point N takes maximum velocity at O point, at midpoint. When x is equal to 0 means when the particle reaches at the midpoint. So its maximum when velocity is maximum. This is plus minus omega. And when x is equal to 0, when x is equal to a actually, when x is equal to the radius of the circle, then it will be v will be minimum, because a square minus a square is equal to 0. So this will be 0. So the projected point n takes velocity 0 at x and x-less point, the corner points, when it touches x-less point or x point, then the velocity will be 0. So this is the equation of the simple harmonic motion, and its maximum values and minimum values. So if you like this video, then like, and if you have any comment, then comment me.